For a two-dimensional potential flow, the velocity potential is given by phi is equals to 4x into 3y minus 4. Determine the velocity at the point 2, 3 and also the value of stream function at the point 2, 3. Here given two-dimensional potential flow, so 2D potential flow, the velocity potential is given by phi is equal to 4x into 3y minus 4. Here given velocity potential function, given velocity potential function, velocity potential function. So velocity potential function denoted by phi. Okay. Here phi is equal to 4x into 3y minus 4. The given velocity potential function phi is equal to 4x into y minus 3y minus 4. So 3y minus 4. Given 3y minus 4. This is velocity potential function. Okay, na? So let us distribute the 4x. Let us simplify this further. 4x into 3y, 12xy. 4x into minus 4 minus 16x. So this is velocity potential function. Here, okay, what we need to find? Here we need velocity at the point 2, 3. So the first one is velocity at a point. Let us name it as the point be P, whose coordinates are 2, 3. So here we have x coordinate and y coordinate. Here x is equals to 2 and y is equal to 3. So we need velocity at point P whose coordinates are 2, 3. Okay. So in velocity potential function, we have three velocity components in general. Anyhow, we are discussing about a two-dimensional potential flow. So in case of two-dimensional potential flow, we have two velocity components, velocity in x direction and velocity component in x direction and velocity component in y direction. Okay, na two-dimensional flow kabatti manaki rende untayi. Suppose three-dimensional aithe u, v, w. Okay, so in case of two-dimensional potential flow, u is equal to velocity component in x direction is equal to minus dou phi by dou x, and v is equal to velocity component in y direction minus dou phi by dou y. Here dou means partial differentiation. Here dou for partial differentiation. We have two types of differentiation: ordinary differentiation and partial differentiation. This is partial differentiation. Okay. So first of all, we need u and v. Okay. So anyhow, how do you get velocity at point P? Velocity at point P, so coordinates 2, 3 is given by, so actually we can say that resultant velocity. Their velocity in the sense resultant velocity. So resultant velocity at point P 2, 3 is given by, so VR resultant velocity is equal to root over u square plus v square. Root over u square plus v square. This is resultant velocity. Okay. So first of all, we need u and v. Okay, now u components u and v. So here u is equal to minus dou phi by dou x. U is equal to minus dou phi by dou x. Let us calculate this. So minus dou by dou x of what is phi? Here phi is equal to 12xy minus 16x. 12xy minus 16x. Here we are doing partial differentiation with respect to x. So with respect to x, manam partial differentiation chestunam. So other than x, so here x is independent variable. Okay, na? Other than x and remaining all terms are constant terms. Other than x, remaining all constant terms. Here we have 12xy. Here x is variable and remaining all constant. Here 12y is constant. So first of all, here minus 12y is constant term. Okay, na? So derivative of x, partial differentiation of x 1. Okay, next minus into minus plus, okay. So now derivative of here 16 is constant, so 16 constant. Derivative of x with respect to x what? 1. So you will get minus 12y plus 60. Minus 12y plus 60. Next, minus dou by dou y of again 12xy. What is 5? 12xy minus 16x. Now we are doing differentiation, partial differentiation with respect to y. So only y ekkadaithe undo, y variable, y ekkadaithe undo manaku only ave manaku variable terms, remaining any constant terms. So here we have y, okay na, this is variable, and 12x is constant, so minus into plus minus, minus 12x, okay na. Derivative of y with respect to y 1, minus into minus plus, okay na. Dou by dou y with respect to y, we are doing differentiation with respect to y. Here we do not have y term, so this 16x is constant term, ikkada y లేదు కాబట్టి ఇది ఏ టర్మ్ అవుతుంది, constant term, okay na. Now what is the derivative for constant term? 0, so you will get minus 12x. So u is equal to minus 12y plus 16 and v is equal to minus 12x. Okay. Now let us find value of u, velocity component u, value of velocity component u at point 2, 3. So x is equal to 2, y is equal to 3. So minus 12 y. What is the value of y here? 3. Next, so here we do not have x term, so no problem. So minus 12 into 3 minus 36, minus 36 plus 16. How much? Minus 36 plus 16, minus 20. So minus 20 units per second. Velocity units, generally meter per second. Okay, anyhow, he didn't mention anything about units. Okay, so that's why we considered units per second. And what about v? V is equal to minus 12x. So what is the value of x here? X value 2. So minus 12 into 2 minus 24 units per second. Minus 24 units per second. So okay, now we have velocity components u and v. Okay, so let us substitute here. So we need resultant velocity at point p 2, 3. So manaki resultant velocity kavali, use this formula. Vr is equal to root over u square plus v square. Okay, substitute u value and v value here, you will get resultant velocity. Okay, now resultant velocity at a point 2, 3, Vr is equal to root over u square plus v square, u square plus v square. So Vr is equal to, u value is minus 20, so minus 20 whole square, and v value is minus 24, minus 24. And Vr resultant velocity at point 2, 3, minus 20 whole square is 400 plus 24 whole square, you will get 576. So Vr is equal to 976, root over 976. So what is the value of root over 970? You will get approximately 31.24 units per second. So this is velocity of the point, velocity at point 2, 3. So this is the answer for velocity at point. We consider p, so p 2, 3. So our point దగ్గర velocity ఎంత ఉంది మనకి 31.24 units per second. Okay, so let's see next part. So what is the next part? Next we need to find value of stream function. Value of stream function, this is very important. Value of stream function denoted by psi at a point p 2, 3, same point. Okay, so now what is the relationship between the potential functions and stream functions? Here this topic is very important. So we know that in general dou xi by, we have a relationship dou xi by dou y is equal to, and dou psi by dou x is equal to. We know that dou psi by dou y is equal to minus u, and dou psi by dou x is equal to v. So relationship between velocity components and stream function. Okay, now these two formulas are very important. Okay, so stream function ki velocity components ki relations. Dou psi by dou y is equal to minus u and dou psi by dou x is equal to v. So we already have u and v. So u is equal to, I think we got minus 12y plus 16. Okay, distribute minus, you will get plus 12y plus minus into plus minus 16. And we got minus 12x. Minus 12x. So here we need value of stream function at point p 2, 3. We need, first of all, we need this psi value. Psi, okay, now this psi function. So let it be equation number 1 and this is equation number 2. Okay, no? So names is equation number 1, equation number 2. To eliminate the derivative. So here we need to eliminate dou by dou x. We have to apply integration. Okay, no? So let us consider equation 1. Using equation 1. So dou psi transpose dou y. You will get 12y minus 16 into dou y. Apply. So to eliminate derivative. So this derivative eliminate cheyalante nenu em apply cheyali? Apply integration with respect to y. Apply integration with respect to y. So integral dou xi. Okay. So if you apply integration, dou xi becomes d xi is equal to 12y minus 16. Dou y becomes dy. Okay. So integral d psi means psi. Integral 12 is a constant. So 12 dy. 12 is a constant. So integral 12 dy. I mean 12 is constant. Integral 1 dy what? Y minus. I think here. 12y. Sorry. So integration of, so first of all let us distribute this. So 12y dy minus integral 16 dy. Okay. I is equals to, so integral 12 is constant, derivative integral y dy. Integration of y emutundi y square by 2. Okay. 2 1s and 2 6 are. Minus integral 16 is constant, integral 1 dy y, and we have a constant k. So this is called constant of integration. Your k is called constant of integration. Okay, now whenever we do integration we get some constant. So especially in case of indefinite integrals. Okay, now? So this is called constant of integration. So integration, indefinite integration cheste manaku constant vastundi eppudu kuda k name anto constant of integration. Next, so xi is equal to, anyhow we got xi is equal to 6y square minus 16y plus k. Now we need to find value of k. Here we need value of k. Ee k kavali, constant of integration. Then we can find value of this function at point 2, 3. So ఈ పాయింట్ దగ్గర మనకి xi value కావాలి. First we need k. How do we get k? Remember, k is depending upon, k is independent of y, but k is depending upon, it depends on x, because k is a function of x. K is function of x. Okay na? ఇక్కడ k అనేది దేని మీద డిపెండ్ అవుతుంది? y మీద డిపెండ్ అవ్వదు, x మీద డిపెండ్ అవుతుంది. So anyhow, here we have one more equation, equation number 2. From equation 2, dou psi by dou x is equal to minus 12x. Okay. So since k is a function of x, apply partial differentiation with respect to x. Okay, now because k is a function of x, k is function of x. Okay, depending upon x. సో k అనేది x మీద డిపెండ్ అవుతుంది కాబట్టి నేను ఏం చేస్తున్నా డిఫరెన్షియేషన్ చేస్తున్నాను. దెన్ ఓన్లీ వి గెట్ dou i by dou x. ఓకేనా? సో ఇక్కడ విత్ రెస్పెక్ట్ టు మనకి dou i by dou x వాల్యూ ఉంది కాబట్టి ఇక్కడ ఆల్రెడీ మనకి ఇన్ టర్మ్స్ ఆఫ్ x నేను ఏం చేస్తాను విత్ రెస్పెక్ట్ టు x డిఫరెన్షియేషన్ చేస్తున్నాను. నౌ dou psi by dou x is equal to, with respect to x we are doing partial differentiation, remember, with respect to x. So other than x remaining all constant terms. So differentiation, partial differentiation of constant 0 0. So this is not constant, this is a function of x. So dou k by dou x. Now dou i by dou x how much? Minus 12x. Okay. So here we need value of k. Now again apply integration with respect to x. Apply integration with respect to x. With respect to x. Integration with respect to x. So apply integration. Integral dou i is equal to, we are doing with respect to x. So when we apply integration, the partial differentiation becomes ordinary differentiation. So similarly integral minus 12x dx, we are doing integration with respect to x. So integral d psi, okay, minus 12 constant in, okay. So integration of x with respect to x, what? X square by 2. So 2 1s and 2 6s are, so here not side k. So here we have to dou k is there, so dk. This is also k, we are finding k value. Okay. Now k is equal to minus 6x square. The value of k is minus 6x square. Now substitute k value here, you will get stream function psi is equals to 6y square minus 16y minus 6x square. So we need value of psi at point 2, 3. Here x is equal to 2, y is equal to 3. X is equal to 2, y is equal to 3. Put x is equal to, so value of psi at 2, 3. 6 into, okay na? Here y is equal to 3. So 3 square minus 16 into y is equal to 3 and x is equal to 2 square. 6 into 9 minus 16 3s are 48 minus 4, 2 square 4, 6 into 4 24. 6 9s are 54, 54 minus 48 minus 24. 54 minus 48, 54 minus 48, 6 minus 24 minus 18 units, minus 18 units. Okay. So 54 minus 48, 6, and 6 minus 24, 6 minus 24 how much? Minus 8. So value of the stream function is at 2, 3 is minus 18 units.